Today we're going to be continuing our cross sections. So yesterday we looked at volume with cross sections. The math we did was just the squares and rectangles, but as I showed you in those little applets, we can have more than just squares and rectangles. We can have triangles, semicircles, pentagons, any of those things we can do. So today we are going to be looking at triangles. We have three different types of triangles that we are going to be using here. Then we're going to be looking at semicircles and quarter circles for our cross-section shapes. So the three common triangles that we'll be dealing with are these: an equilateral triangle, a right isosceles where the leg is the base, a right isosceles where the hypotenuse is the base. I have given you the equations for the area based on, well, the base of that shape. I'm going to go ahead and show you how those areas are derived so you know where they come from. However, once you know where they come from, you can just use the areas. These area equations are ones that I would recommend that you commit to memory at some point. Okay? So starting with an equilateral triangle, what is special about an equilateral triangle? All what is the same? Sides, and we can use tick marks to show that congruency. Now, we want our area to be based on the base. So this down here, because that base is what is going to be our top minus bottom, or right minus left. Now I'm telling you the area is rad 3 over 4b squared. How do we get that? Well, to be able to do it, so again, the entire length here is we call our b. If that is our base, our b, then this is also b and that is also b. To be able to find the area of a triangle, what's the area of a triangle? Just in general, what's the area of a triangle? Half of the base times height. Some of you guys said it in a different way, but yes. Base times height, half of that. Do we have our base? Do we have our base down there? The height would be the one that comes straight down. In an equilateral triangle, that height is what we call a perpendicular bisector and an angle bisector. What do I mean by perpendicular bisector? It splits the base in half at a right angle, perpendicular. So then this is congruent to that one. And we can write that length here as half of the base. And this right here we'd say is our h. Another term that we don't often use for equilateral triangles is that equilateral triangles are also equiangular, meaning all the angles are congruent. Well, all the angles in a triangle add up to 180 degrees. If they're all the same, then I can divide by 3, and I have 60 degrees for each of my angles. That height is also an angle bisector, so it cuts that top angle in half. So I have 30 there for that right triangle. Now, with that information, I could then, I have a couple options to find the area, because I need my height in terms of b, so I can then write the equation that I have down here. We can use either trig, or we can use Pythagorean theorem. I'm going to use trig, SOHCAHTOA. So I'm going to use that sine of 60 opposite over hypotenuse would be h over b, opposite over my hypotenuse over here. Well, how do I solve for my h? I just multiply by b. So my h is equal to b times sine of 60. Well, unit circle, what is sine at 60 degrees? Rad 3 over 2. So I am going to go ahead and use that now in my equation over here. So that means I am going to have 1/2 times the base. My height I am writing as rad 3 over 2 times the base. Well, if I multiply things together, that would be rad 3 over 4 b squared, which is what I have here. Exactly. So this is where it comes from. That's a lot complicated. The other way is to use the Pythagorean theorem, which you totally can. It would be h squared plus half b squared equals b squared, and you can solve for h that way. All right. The other two are easier to figure out where the equations come from. Is everybody good with the equilateral? All right. Right isosceles. What is special about an isosceles triangle? Two are the same, the legs specifically. And in this case, my leg is my base. Again, that base would be my right minus left, or top minus bottom. So that entire length we say is b. Well, if that is b, then the other leg is b. And what's the equation for a triangle area? 1/2 what? Base times height. But my height is also b. And what is b times b? So that is 1/2 b squared. And that's what we have down there. It's a lot simpler. Now, yesterday when we did squares, what was the area equation for a square? But in a square, what is the height? Also the base. So base times height for a square would be base times base, or so I have half b squared. So another way of thinking about this is that this is half of a square, which actually we can visualize. I can bring out to here, and I can connect these, and that would make a square. And that triangle's half of it. Half of my square. B squared. Sounds easy. All right, our third one, right isosceles, but this time the hypotenuse is the base. So it is an isosceles, but these are congruent sides. The hypotenuse this time is our base b. Look at the equation. What does it say? 1/4 b squared. Thinking about it like we said over here. How much of a square then is this? 1/4 of a square. So this is 1/4 of a square, which we can visualize by extending these up. A base or a square has the same sides, the same. And that would be my square, where these are all my congruent sides. All of those are b. And that triangle is 1/4 of b squared. All right? So the equilateral triangle on this one is the one that's a little bit more tricky to get the equation from. These ones are just half of a square and a fourth of a square. All right? Any questions? Nope. All right. I'm going to try problem number 2. It's non-calculator. So problem number 2. Why did I say 2? Number 1. Find the volume of an object with a base bound by the x-axis, x equals 9, and y equals square root of x with isosceles right triangle cross sections. The cross sections are perpendicular to which axes? So what are we in terms of? We are in terms of x with the right angle along the x-axis. All right, what is our cross-section shape? What do they say? All right, isosceles right triangle. I have 2 of them, so which one are we using? Leg as the base or hypotenuse as the base? There we go. All right, we do have information. Maddie, say that a little louder. What piece of information tells us which one we're using?
The right angles along the x-axis.
This piece down here. So which one would we use at the right angles along the x-axis? The leg as the base. So we are doing leg as the base. Okay, the right angles along the x-axis. Okay, so in a sense, we want to think this right angle that we have right here is going to be along that x-axis. We'd have triangles that be coming like out, and there'd be a right angle happening there. It's not very well drawn, but you get the idea, right? So we now know which one we're going to be doing. We know our cross section. We know we're in terms of x. So our cross section is going to be that right isosceles triangle. There we go. Right isosceles triangle. These 2 are congruent, and that's my B. That B is going to be, which one is it going to be? Top minus bottom or right minus left on this one? So we're going to have top minus bottom. That's going to be my B. Okay? Well, what is my top? Square root of x. What is my bottom? The x-axis, which would be 0, right? We could say that is y equals 0 down there. That's our x-axis is the bottom. So then our base is going to be square root of x, zoom on that here, minus 0, or just square root of x. What is the area equation for our for this triangle? What do we have up above? Base times height and what? Half of it, right? So that's going to be area is going to be 1/2 b squared. Well, what is my base? What happens when I square a square root? So my area equation is just 1/2 x. And that is what I'm going to put into my integral. So we're going to have the integral from where to where? What are our bounds for this integral? 0 to 9. And I have 1/2 x. That is that area equation, dx. All right, you guys should be able to evaluate that. Go ahead and do so. Non-calc, please. Should be fairly straightforward. Go ahead and do that. So what is our antiderivative, guys? Yep. 1/4 x squared from where to where? 0 to 9. So let's plug that in. 1/4, and I have 9 squared minus 0 squared. What is 9 squared? So then my answer is 81/4, and I'm done. All right, good. Problem number 2. That one is calc-aloud. I want you guys to go ahead and try it. Next few minutes, please. We are perpendicular to the x-axis, and our shape is an equilateral triangle for our cross-section. All right, go ahead and try it out, please. In a minute or so, I'll give you the answer, but not the solution yet. So on this problem, you will have to calculate your intersection points. So for both of them, I would recommend, yes, I am. I would recommend that you store those intersection points in your calculator. If you're using your TI, calculate your first one, store it in a variable. Calculate the second one, store it in a variable. I would use A and B personally. If you're using Desmos, then copy and paste those intersection values for those x values. Okay? If you're getting close to an answer, here it is. All right, a couple more minutes, and then I'll put up the solution. Again, we needed to calculate those intersection points. So this one is at 0.635. Second one looks like it's 5, but it's not. It's 5.011. It's not exactly 5. All right, cross-section is the equilateral triangle. Our base is top minus bottom. So our sine function minus the quadratic function. Our area is rad3/4b squared. So then in our integral, that's going to be the integral from 0.635 to 5.011. Again, in your calculations, you may be writing down 3 decimal places, but in your calculator, you should be using more than 3 decimal places. Bare minimum should be 5. That's what Desmos gives us. Preferably more. Our TI calculators give you more, so you should be storing those. Inside should be rad3/4. And then our base, the sine of x plus 2 minus x squared minus 6x plus 6. All that squared. Please be careful that you are using appropriate parentheses, or that you simplified your b appropriately. I had somebody second period that did not distribute the negative to the second term, and they still had a negative 6x instead of positive. So please be careful with that. All right, any questions or clarification needed on problem number 2? We good to go, guys? All right, let's turn the page. Okay, we are looking at semicircles and quarter circles. One thing that we might have to use at different places is the equation of a circle centered at the origin with a radius r. That equation is x squared plus y squared equals r squared. It looks like the Pythagorean theorem because it kind of is. But that is our circle equation. A semicircle. How much of a circle is a semicircle? Yep. So that is why my area equation is half pi r squared. Now, for our cross sections, if you have a semicircle, then the entire diameter of the semicircle is your base. That whole thing is b, from there to there. So that diameter would be your top minus bottom, right minus left stuff going on. However, if we want to have our equation in terms of b, then we need to replace r with something in terms of b. Well, r is our radius. Well, radius is half of the diameter, right here. So then r would be half of our b, because that is what our radius is, which we have right there. Well, if I take this equation and I substitute in that 1/2 b for r, let's see what we get. So it'd be 1/2 pi times 1/2 b squared. Well, what is 1/2 squared? Half times a half. A fourth, right? So that would be 1/2 pi, 1/2 b squared. But then what is 1/2 times 1/4? 1/8. And that is how we get that equation. So if the base is the diameter of a semicircle, then we have 1/8 pi b squared. Usually. All right. Quarter circle, as we know, is, well, a quarter of a circle. That's why we have 1/4 pi r squared. If we have a quarter circle, this would be the base of our top minus bottom or right minus left. Well, what is that in a quarter circle? That is the radius. So therefore, the radius is our base, because this is our base down there. And so that's where we have that right here. And if I take 1/4 pi r squared and I replace r with my b, I would, well, have 1/4 pi b squared. So that one doesn't really change like it did with the semicircle. So those are going to be our two equations that we're going to be using, one for a semicircle and one for a quarter circle. So we have an object. The base of the object is bound by x-axis, y-axis, and y equals square root of 4 minus x. What is our cross-section shape? All right, so we have that area formula up above. And what are we in terms of? Because we are perpendicular to which axis? The y-axis. So we have to remember that we are in terms of y. So that means, are we doing top minus bottom or right minus left? What is our base going to be? Right minus left. Well, what is our right-hand equation? Y equals the square root of 4 minus x. Is that in terms of y? So what do we have to do with it? Isolate our x. How are we going to do that? What do we do to both sides? So y squared equals 4 minus x. And then you have a couple options. Some people like to minus the 4 and then divide by negative. Some people like to add the x and then minus the square y squared. Doesn't matter. Your end result is going to be x equals, you can either write it as negative y squared plus 4 or 4 minus y squared. Either way would be correct. So that is our right. What is our left-hand equation? What's the left-hand equation? Yep. 0, our y-axis. All right, our cross-section is a semicircle. And our base is going to be that right minus left. So 4 minus y squared minus 0. What is the area equation for a semicircle? 1/8 pi b squared. So then that would be 1/8 pi times what squared? Squared. All right. Let's go ahead and set up our integral then. Our volume would be the integral from where to where? 0 to 2. Remember, we pick it from the y-axis if we're in terms of y. And our area equation is going to be inputted in. So we have 1/8 pi times 4 minus y squared squared dy. There we go. All right, go ahead and throw that into your calculator and see what our answer is. Okay. Your favorite numbers, guys. 6.702. All right. Any questions on that problem? No? No questions? All right, I want you to turn the page and try problem number 4. Also, calculator allowed. Just because the bell's going to be ringing soon, I'm going to put up the solution. So don't pack up yet. All right. So our the top equation is our arctangent. The bottom equation is x equals e to the negative y, but we are in terms of x. So you have to solve, and y equals negative natural log of x. So that's your bottom, top minus bottom. We do have to calculate that one intersection point, that's 0.587. The right-hand side is 2. And then our equation is 1/4 pi b squared.